So we've got a pallet here of cat food, and straight away what we're seeing is we've got corner crush damage on the boxes. What we're seeing as well is these hazy lines here is where we've got stretch left in the film because the machine isn't set up correctly for the film, and so we're getting a huge amount of slippage. And if we find there we go, you see how easy that film can be stretched out there. What that is a huge amount of stretch left in that film. What that does is it allows the load to shift in transit, and the wrap will become baggy, and we'll see the load shifting and moving, which is very dangerous. So what we'll do is we'll cut this wrap off and we'll weigh it, and we'll calculate from the number of rotations, we'll calculate the actual pre-stretch that's been applied to the pallet, and then we'll come up with a alternative wrapping program with a better film. And let's see if we can solve all these issues that we've got here with the tail ends, with not wrapping to the pallet, with crushing the boxes and eliminating the slippage. So we've just about finished building up the testing kit that we've got. It's a fantastic bit of kit. What you've got is a series of load cells which you build up the side of the pallet, and that will then transmit data through to the computer here, which will give us a profile of exactly the force of the film against the product all the way through the cycle. The beauty of this system is that we can have it on small pallets or big pallets, and we get an accurate result every time because it's always in the same position. So we've got our testing kit all loaded up, ready to go. We've got the 15 micron extremis film on the machine. It's stretching at about 300%. Let's hit the button and see what it does. So this is wrapping in the extremis 15 film, 12 revolutions, same as what we had before. And if you notice straight away, you see the clarity of the film. It's you haven't got any of the shimmery slip bands on it because it's applying the film very nicely. We've got a constant pressure throughout, and we can increase the tension, I believe, but we don't want to go too far because we don't want to damage the corners. We don't want to crush the corners. But what you see straight away is the film. We find a join here. The film is pretty much locked out. So we only have a small amount of stretch which you need just to compensate on the corners. But you've got a load there which is a lot more stable. So let's cut this film off and weigh it. So let's weigh them. So this is the original one. "282 grams. Let's try the extremis Nano 15. 105 grams. Good, so we're using the extremis 15 film still. What we're doing now is we're putting some additional revolutions around the bottom of the pallet to get the stability, and we're going to bring the film coming up the pallet slightly slower to get more overlap. I still believe that by doing so, saving lots of money by preventing damages and returns in transit. So let's try it. You look at the clarity, the film's there, but what you will notice is we're not going to have the same corner pressure on the product that you've got currently. See that we've got a nice tight wrap around it, but it's not crushing the boxes at all. Let's have a look and see where the film is. There you go. The zone that we want to be in with what's left in the film, just a little bit to allow for your discrepancies on the corner. Good bit of tension there. That pallet's not going to go anywhere.